Hello everyone. Today we're going to be tackling the ultimate Leetcode problem, the one that nobody can seem to solve in interviews, reversing a linked list. Yes, you heard it. We're going to reverse a linked list today. So, the general idea behind this problem is we're going to be given a head of a singly linked list. So in this case, we're going to be getting one, and what we have to do is return the reverse list. So let's get to it. So the general idea behind this problem is we're going to be given, for example, like three nodes like this, and they will all be connected in a chain like this. I'm sure all you guys know what a linked list is. And pretty much the goal of this is we want to return a list that looks something like this. So we have it pretty much in reverse order. So three, two, one. And now you guys may ask, how can we solve this problem? So there's two quick ways that this problem can be solved. This can either be solved recursively or iteratively. And the way we're gonna do it today is iterative. Man, I can't say that word, but who cares? Okay, we'll just keep going. So this is how we're going to solve this problem. So to start out, we're going to create two pointers. And our first pointer is going to be our current pointer, and our next pointer is going to be our previous pointer. And pretty much, since we're going to be starting from the beginning of the list, since we're given the head, we're going to set our current pointer to the head of the linked list. And as you guys can see, there is no node that is previous the head node. So our previous pointer is going to be set to none to start out because as y'all can see, there is nothing there. So the general idea behind this algorithm is we want to take this link right here, and instead of pointing it at 2, we want to point it at the previous node. So the way we can do this is we can create a temporary pointer, and this temporary pointer is going to be set to current.next. So in this case, it's going to be 2. And the reason why we want to do this is once we reverse that link right here, we're going to lose a reference to this next node. So we are creating this temporary pointer to make sure that we don't lose that. So what we're pretty much going to do is we're going to take this link right here. We're going to instead set the current.next to be the previous node. So we're going to reverse it this way. And as you can see in this case, the previous node is none. So this is going to become the tail node, and its next node is going to be none. And as we still have the reference to the temporary node, what we're going to do is set the current node to be the temporary node now. And then we're going to set the previous node to be the current node we were just at. And that's pretty much how we're going to generally solve this. We're going to pretty much repeat this iteratively throughout the linked list. And as we keep going, we're pretty much just going to keep reversing these links till we get to the very end. So we're going to get to the very end. And then eventually we're going to be at none. And that's when the loop is going to end. So for this algorithm, we're actually going to have to loop through every single node. So that means we're going to have O of n time complexity. But as we're not really creating a new array or anything like that, we're also going to have constant time for space complexity. So yeah, let's get to coding out the solution. So coding out the solution is actually really simple. So what we want to start out by doing is creating a current pointer, and that's going to be set to head. And we also want to create a previous pointer, and we're going to initialize that to none. As we stated before, there's nothing previous the head node, so it's going to be null to start. And then we want to say while current is not none, so we're going to keep looping through this linked list until we reach an empty node, which just does not exist. We're going to set a temporary pointer to be current.next. And then we're going to set current.next to be a previous node. So what we're pretty much doing here is reversing the link. And then we're going to set the previous pointer to be current. And then we're going to set current to be temporary, which, as we stated before, is current.next. So if we run this code right here,
Oh man. Oh, we forgot one step. We now have to return previous. And the reason we are returning previous is because this is going to be the last non-null node. As we are currently looping till current is not none, at some point the current node is going to just be null. So we want to return the previous one. So if we submit this again, there we go. Reversing a linked list. Wasn't that bad.